Welcome to the project demonstration of design and implementation of intelligent energy distribution management with photovoltaic system along with IoT. So in this version we have added the IoT feature to monitor the net metering concept data of power consumption by the home and how much of power we sell to the government outside of the house. So that will be continuously monitored from your ThinkSpeak application website. And in this one, two fields will be there. Field 1 is nothing but home kilowatt hour, and field 2 is outside of home, the how much of power you sold to the government, so in kilowatt hour. So these readings will be continuously monitored on the 16:2 LCD screen as well as on the ThinkSpeak. So the main application of this project is, so if we install a solar panel on our house, after that we can utilize this power by our own, and that will be measured by this energy meter. If in the daytimes you are not in the house and if you want to sell the power to the government, and that will be measured by this energy meter. So the net concept nothing but how much of energy consumed by you and how much of energy you sold to the government, and that will be displayed on the LCD screen by like subtracting them, like how much of if the power sold to the government is more than the consumed by you, then you can get the power curve like money from the government, they will pay you directly. So that readings also displayed on the LCD screen as a net net, and the consumer has to pay or government has to pay, that string also will be displayed on this LCD screen. So we have interfaced these two energy meters to the microcontroller through this optocoupler boards. So the main purpose of this optocoupler boards is like we are going to calculate the power consumption from this energy meter LED indication. So we need to count the pulses from this LED blinkings, and if you interface the LED directly to the microcontroller, if anything goes wrong inside the energy meter, there may be a chance of damage to the microcontroller. In order to prevent that, we need to make a isolation between the inputs and the microcontroller. For that isolation purpose, we are using optically coupled optocoupler, that's PC817 IC. I mean, if anything goes wrong inside this, then only the IC will get damaged. Just by replacing the IC, we can protect the remaining main motherboard and our Wi-Fi module along with the display section. And we have interfaced this energy meter 1 at A4, energy meter 2 at C0, and LCD display at pin number B22, B7 and B0, B1 for the ESP8266 Wi-Fi module. So the whole system getting power supply from this 230 volts AC input parallelly distributed to the energy meters as well as to this regulated power supply board, so which will take 230 volts AC input and provide us the 5 volts DC output. Once we provide the 5 volts DC to this one, it start reading input from these two energy meters and calculate the kWh and display the final kWh and upload the same data to the ThinkSpeak cloud platform for every 10 seconds of duration. So let us see demonstration. Before on this, first of all we need to enable the hotspot in your phone. So for that, go to hotspot settings and configure the hotspot settings to project 6325 without any space, without any capital letters, and password should be 123456789. So after configuration this, on the hotspots along with data, now on the power supply to this system, there we can see one device will be connected in your mobile phone. Right, you can see the one device connected in your mobile phone. Sorry, it on the hotspots, and reset this. Right, you can see device got connected, and now go to the ThinkSpeak cloud platform. So this is the previous data. So on LCD display we can see that as of now demonstration purpose we kept the 100 watts and 200 watts bulb. So we can see the readings on this one. So right, the home consuming the less power as the government consuming the more power. That's why minus nothing but the government will have to pay to you. So you can see that the government or pay the units, the minus. And now here for data, right, we can see the data is uploading to ThinkSpeak. So in order to clear the data, old data, if you want to get the fresh data, now go to channel settings here. Before the erasing the data, you can download them. So to download the data, go to data import export, and in that download the data. So it will be open in Excel sheet, and we can see the data along with date and time and how many samples till now collected, entries, and field 1 and field 2. Field 1 is the home, field 2 is the government, right? We can see this along with date and time and samples till now collected. So after you took the backup, now you can erase that. To erase, go to channel settings, and in that only do clear channel, only do clear channel. Okay, so I'm repeating: private view to see the live data, channel settings to clear the channel, data import export to download the data. Now the old data got erased. Wait for the new data to be arrived into the ThinkSpeak. As we discussed, it will take 10 to 15 seconds duration as the ThinkSpeak accept the data for 10 to 15 seconds duration. Right, we got the new data here. Click on that, we can see the home kWh along with date and time. Same here also. Right, so the kWh calculation will be done based on the LED blinking rates. So when we purchasing this energy meter, on the energy meter box we can see the 3200 impressions per kilowatt hour. Means whenever the LED blinking rate reaches 3200 counts, then the load connected to the energy meter was consumed 1 kilowatt hour. So now if one blink was received from this LED to the microcontroller, then we are making it as 1 by 3200 kilowatt hours. So like it's going to be the 0.0003 kilowatt hour readings. Same will appear here also on the LCD screen also. Right.